Hello folks, this is Mr. Dan coming to you from the landscape design classroom, and today I'm going to talk to you a little bit about feeding hydroponic plants. So main idea here is how can I provide plants proper nutrition when growing them in a hydroponic system. So from our last lesson we found out that a hydroponic system is a water-based growing system that actually doesn't use any soil. So we have a few different types, but we're going to talk about feeding plants today. So plant nutrition, the key to successful hydroponic food production. So what we found out in our last lesson was it takes a mixture of different water-soluble nutrients to have a successful system, and it also depends on the type of system that you want to use. In the picture down here below, we can see a photo of nutrients being added to the system, and she's actually using a test tube or something to measure how much is going into that system. So it requires careful monitoring. Like I said in the our last presentation, you have to make sure that you are always continually monitoring your system, because just like a regular growing in through soil, you want to make sure you're checking for bugs, diseases, insects. Check your timing on your water-based growing, and just overall maintenance on that system. So, plant matter. So 85% water, 15% dry matter. So 90% comes from water and the atmosphere. So that's carbon, hydrogen, and oxygen. 10% of other elements absorbed from the soil or from the hydroponic nutrient solution. So most plants, whenever you get them, are going to be 90 or 85% water, and that dry matter going in is going to be coming from the hydroponic nutrient solution. So essential elements for plants, macronutrients needed in relatively large amounts, and micronutrients, which are needed in smaller amounts. So if we take a look through all these different elements down here, we're going to have a lot of different things going in, such as calcium, magnesium, sulfur, phosphate, chloride, a bunch of different stuff, and it all depends on the type of plant that you're trying to grow. So as I always say a million times in these presentations, always make sure you're reading your label and doing your research before you just kind of start going ham into this. So some macronutrients, the larger ones, they include carbon, nitrogen, potassium, sulfur, a lot of different ones that you guys can take a look at over time. Some micronutrients would be iron, chlorine, zinc, copper, molybdenum, and hydroponic nutrient solution. This is one of the most important things to your hydroponic production, because this is exactly what you're putting into the plants and into that water system. So it provides water and all essential elements, inorganic fertilizer, salts dissolved in water. So you can mix your own, or it can come pre-mixed and adjusted for the crop being produced. So I always recommend a mix your own, because if you're buying pre-mixed, you're going to spend a lot of money. If you have the luxury of being able to make really good sales on a pre-mixed blend, then I would recommend doing that. But for the most part, I would mix your own. And as I said, just monitor and adjust for whatever crop you're trying to produce. The nutrient solution considerations, plant species and variety, stage of plant growth, part of the plant to be harvested, the day length, what season is it in, how many days until harvest, the weather conditions surrounding it. For what you're going to be doing in here, it will always be optimal conditions, because we will be in an inside environment. So nutrient solutions, we have our pH scale at the bottom, just to go over that again. Our base is neutral distilled water, here it's 7. And then acidic would be all the way down to battery acid, and all the way up on alkaline would be something of a bleach. So it should be well aerated. So you want air coming into your water, into this solution. So ideal pH is going to be 6.0 to 6.5. You just want it slightly acidic. Usually when you get an alkaline, you're not going to get as good a growth. But the more acidic you get, the more devastating it can be to the plant. And understanding pH. So as I said before, numbers below 7 are going to be acidic. At 7 is neutral, and above 7 is going to be alkaline. So different fertilizer salts, these choices should be based on a few different things. So cost, like I said, make sure you try to mix your own stuff because you're going to be paying a lot for mixed chemicals or mixed solutions. Availability, solubility in water, and chemical composition. So solubility is an important issue because you want something that's solid that's going to go away over time and dissolve into the water to feed your plants. So something that's completely solid and never does anything isn't going to help your plants at all. And if it dissolves too quickly, you might be getting too much to your plants at once. Careful measurements, and then moving into water quality considerations. Water test for pH, calcium, magnesium. You want to test for all these things because if you are off, sometimes even slightly, you could kill your plants. So more expensive, it's extensive testing for larger systems. So well, the one we do in here, we'll check it daily for stuff, but some of those tests we won't do as often. Typically, I like to do a pH test every day just to make sure that the right pH is going in, or the right pH in your water for feeding your plants. And then groundwater tested for herbicide residues. So any of your water that you have going through, you want to make sure that you are testing, especially if you're pulling it right out of a spigot. We typically don't pull water from the outside because we don't really have anything around the school to do that anyway. So we want to make sure that we are pulling if we are doing something groundwater or tap water, we want to make sure we test that immediately to see what we need to get out of that water. So nutrients and pH in constant change. Water evaporation, plants removing nutrients and closed system can take 2 to 3 weeks before replacing, up to 2 months with weekly chemical analysis. Water added daily for constant volume. So water is going to evaporate. The nutrients are going to be sucked up by the plants. So we need to make sure that we are testing continually to make sure that we're getting those plants the right stuff that they need. The electrical conductivity meter to measure solution salts. So one of the biggest issues that you can ever have in water is salt. Salt is absolutely needed, but in high amounts it will kill your plants. pH monitoring. So again, we want our pH to be at about a 6.8 to 6.5, so just slightly acidic. Phosphoric or sulfuric acid to lower the pH, and potassium hydroxide to raise pH. So injectors for automatic pH adjustment in large hydroponic complexes. So on the right, you have a picture of somebody doing some pH testing, and it looks like they're testing at a 5.91. So they're just slightly below where you want to be at 6. So in an open hydroponic system, nutrient solution is not recycled. So that's going to, you're going to have to continually be putting some kind of nutrients into those plants, whether you're spraying them on or have some kind of irrigation system going into it. But remember, this is not going to be replaced. So fresh and nutrient solution, drip irrigated each irrigation cycle, like I was saying, and then no need to change the nutrient solution. Irrigation system includes tubing, pumps, and tanks, and it typically recycles, chemically inert to avoid toxicity. Periodically clean to flush out accumulated salts. Like I was saying before, a ton of salt is not going to do your plants any favors and might possibly kill it. So you want to make sure you're continually cleaning the stuff out and testing to see the salt levels. Monitoring the crops. Plant tissue samples for foliar analysis. Nutrient solution tests. Visual diagnosis. So you want to take a look at your plants every day. If you sense something's wrong, then you want to get into some more of these other tests. So you want to make sure you're testing your nutrients constantly and taking samples and doing some different type of analysis. So that is the end of my presentation on feeding plants through a hydroponic system. We will be continuing this into next week and for the next few weeks because hydroponics is a very big deal in our industry. So if you have any questions at all, please give me a call down here at the Landscape Design Classroom. But thank you, folks, and have a great day.